I think that we're obviously back here again, and then I just want to show off like my skill as like a F5. Like even if I go into the interview, I just gonna do F5. Like I don't know what else to show really. I only can show this, So what I just feel that is that when you're calculating this, you're actually accounting the max of this entire place and this entire place. So I'll call it like phase one. And what phase two does is that phase two is like taking the minimum of this and this. So for this case, so we our max here is 3, right? Obviously. So you have 3 here. Here is a 1. So minimum of these two will be 1. And then 1 minus the height, 1 minus 0 equals to 1. So let's move on to the next one, right? So we got this entire t place and this entire t place. So the max over here is 2, right? Here is 3, right? So minimum of both is this 2. 2 minus 1 will be 1, which is correct. Now move on to the next one. Entirety place of like this whole area. Entirety place of like this whole area. The max over here will be 2. Here will be 3. So 2 is the smaller one. 2 minus 0 equals 2. You still get the answer. And the next point I actually want to talk about is like, why does this work? Why do we create like a wall of the biggest over here and biggest over here, and then choose the minimum of this? So let's break it down in terms of like the stage 1 and then the stage 2, right? So the stage 1 is taking the max over the left and the right. What I can fulfill it, or what I can see is that, okay, if there is like something that is like omega huge, no matter where it is, it can be here, it can be here, it can be here, right? There will be something that is like acting like a wall, so it's like saying that, okay, I have a unit over here, and I don't care where your wall is. So as long as there's a wall, over here, the water can't overflow over this wall. So same goes for here. Like I don't care where your wall is, I can even go until this area. And now if my water want to actually overflow, it need to go through the wall. If it touches, it doesn't matter. It needs to go over and beyond the wall to be able to flow through it. So that's why we need the max. That's why we need the stage 1. So that's the thing about stage 1. And for stage 2, it's like taking the minimum of either of this. The reason why is because, okay, say you have the water again, and then the same old wall, right? The same old wall. The thing is, what if like one wall is shorter than the other, right? What if this wall is just this height, right? I don't care how big your this wall is, it will still be able to overflow here. I don't care how big this is. Your limit, your height will be bounded by here. So it doesn't matter how big your wall is. Your wall is low on the other side, it's just going to overflow no matter how tall this is. So that's why we do the stage 2. And that's why the stage 2 taking the minimum of this 2. And then after you know like the height of how big your wall is, you got to take the height into account of this little water that you are having. If it's like 1 unit height, you only can store 1 water. So here is 2, right? And here is 1 unit already. You only can store 1. but if here is 0, you can store 2 units of water, right? 2 units of water. But for this case, you only can store. That's why you use the minimum of this minus this, you get the thing. First and foremost, I'm very glad that I came back into this solution to actually talk about it. It just happened very coincidentally that I actually come back here to actually solve this problem as a whole. So I'm pretty much thankful. So in terms of like explanation for this, if say my wall over here at the current unit is like 3, right? It will obviously overflow from here. Yeah, sure, it will gonna block by here, but I mean after we go through the stage 2, as we said, we only care about this, right? Because we don't like rinse and repeat. This, no matter how tall this is, doesn't matter. We take account for the minimum one, which is what stage 2 is talking about. I think for this stage, I guess this one will be stage 3. Stage 3 is like talking about how big is my current pointer is at, right? So if the thing is like 3, it doesn't matter. So to put it into mathematical terms, is like your stage 2 minus your stage 3. So this stage 3, based on where it is, so for this case it was 1, so we're having 2 minus 1, which is 1, and for here it will be, the stage 2 will be 2 minus 0 equals 2 units, and for here the minimum of the stage 2 will be 2 minus 1 and get 1 unit. So yeah, rinse and repeat this and this, and that you have it. So yeah, everything comes to an end.